everyone, welcome to the Ramanujam School of Studies 0 to Infinity. Here, the meaning of 0 to infinity is we start our lecture from the concept level 0 and grades up to higher level. Here, we will discuss about higher school mathematics. Basically, we will discuss the class 11th quadratic equation, and this is the lecture 1, and here we define the definition of quadratic equation. Now, this lecture is delivered by Diwakar Bhagat. So, moving to our first slide. Our first slide here is today class agenda. That is what we have to learn here in this class. So, here we learn about the meaning of quadratic equation. What is the meaning of quadratic equation? What is the solution of quadratic equation and its meaning? What do you mean by perfect squaring? And how many there are roots of a quadratic equation and nature of roots? So, first of all, we see here the definition: an equation which contain a square of unknown quantities. Unknown quantities means variable but no higher power. It means we have the power of unknown quantity maximum 2 is called quadratic equation or an equation of the second degree. Now, if the equation contain both the square and first power of unknown, it is called adfacted quadratic, and if it contain only the square of the unknown quantity, it is said to be pure quadratic. Means if we have an expression, an equation, that is x square, right? Here we write x square plus x plus 1, this is equal to 0. So this is adfacted quadratic equation because here we have the power of x is 1 and x square minus 9, this is equal to 0. So this is the pure quadratic equation because here the power of x is equal to 0 and power of again x is equal to 2. That is, this is a second degree equation. Now moving to the second next slide, we have equation, expression and identity. What is the basic difference between equation, expression and identity? So an equation is an equality which is satisfied by some particular value. Suppose we have x plus 2, this is equal to 1. So here we have an equality, and if we put x is equal to minus 1, so LHS is equal to RHS. So this equation is satisfied by some particular value. So this is an equation. If we talk about the expression, so x plus 2 is an expression, and we can write here px, this is equal to x plus 2. So putting different value of x, we get different value of x plus 2. So this is an expression. And if we discuss about the identity, an identity is that which is always true for all value of x, that is all value of real value. Suppose we have x plus 1 to the power 2, this is equal to x square plus 2x plus 1. Now whatever we put the value of x in LHS, we get the same value as we put the same value of x in RHS. So we get LHS is equal to RHS for all real value of x. So this is an identity. Hope you understand the difference among equation, expression and identity. Okay, now an equation in the form of ax square plus bx plus c, this is equal to 0. This is called as a quadratic equation. Why this is a quadratic equation? Because here the power of x variable is maximum 2, that is the integer power, and again power of x is 1. So this is a quadratic equation. Here if a is equal to 0, we get the equation bx plus c, this is equal to 0. Now here the power is 1 and the power of x square is vanishes. It means for a quadratic equation ax square plus bx plus c to be a quadratic equation, when and only when a does not equal to 0. If a is equal to 0, then it becomes a linear equation. So this is the basic definition of the quadratic equation. Either b may be 0 or either c may be 0, but a cannot be 0 for a quadratic equation. Now any value of x which satisfy LHS is equal to RHS is called its root. Okay, now here the solution of quadratic equation, how can we find the equation solution of a quadratic equation? Here we discuss about the perfect squaring. What do you mean by perfect squaring? Perfect squaring means we try to convert the expression of LHS in a perfect square. So we have ax square plus bx plus c. This is equal to 0. So this is quadratic equation, and here a does not equal to 0. Now see here, we can multiply both side by a, so that we have a square x square, okay, a into b into x plus c into a, this is equal to a into 0, so this is equal to 0. So multiplying both sides does not affect the equation by the same. It means here we use the axiom that multiplying equals to the equals must be equals. Now we can write here ax x square, a square x square as ax x square, ax to the power 2, plus here abx can be written as 2 into a into x, because here is a, so we can write here a into x, and we can multiply it to b over 2, right? So 2 and 2 is cancel out, so we get in fact abx. Now here we have, if we assume that this is alpha and b by 2 is beta, so we can write further here we assume for second simplicity, so we can write again here b by 2 to the power square, so this is beta, suppose, so this is beta square, okay. As we add b by 2, we have to subtract b by 2 square, so that there is no change in expression, okay. Now plus we have c into a, so we can write here a into c, this is equal to 0. Now see here, ax is alpha, so this is alpha square, ax is alpha, so we can write alpha plus twice into alpha into beta, and this is beta square. So here we get the formula alpha plus beta square, that is alpha plus beta to the power 2, so we can write here ax plus b by 2 to the power 2. This is equal to, we transpose b square by 2 and ac to the right hand side, so we can write here b square divided by 4 minus ac. So this can be written as b square minus 4ac divided by 4. Now we have ax plus b by 2 to the power 2, so taking a square root both sides, we can write here ax plus b by 2, so this is equal to square root of, we have b square minus 4ac divided by 4, okay. So we can further write it as a, and here we have square root of b square minus 4ac divided by 4, so we can write further this is equal to plus minus under root b square minus 4ac divided by 2. So we can again write it ax, this is equal to minus b over 2 plus minus under root b square minus 4ac divided by 2. So we have x is equal to minus b over 2a plus minus under root b square minus 4ac divided by 2. On combining 2 into a, on combining we can write here x is equal to 2a minus b plus minus under root b square minus 4ac. So we have here two value of x. When we take x as, when we take plus sign, we can write here x1, so x1 is the first root, so this is equal to minus b plus under root b square minus 4ac divided by 2a, and if we take negative sign, so we can say that this is second root, that is x2, and this is equal to minus b minus under root b square minus 4ac divided by 2a. So here we see that a quadratic equation has two roots, one when we take plus sign and another one when we take negative sign. So it has two roots. So suppose we think that the quadratic equation has more than two roots. So here we analyze that a quadratic equation cannot have more than two roots. How? Suppose alpha, beta and third root is gamma are the three roots of an quadratic equation. A quadratic equation, that is ax square plus bx plus c, this is equal to 0. Since alpha, beta and gamma are the roots of the quadratic equation. So we can write here a alpha square plus b alpha plus c. This is equal to 0. Beta is also a root of quadratic equation, so it also satisfies the given equation. So a into beta square plus b into beta plus c, this is equal to 0. Suppose this is equation first, this is second, and third one a gamma square plus b gamma plus c, this is equal to 0. So we have three separate equation for each root. Now if we subtract 1 from 2, so this is 1. So if we subtract 1 minus 2, we have a alpha square minus a beta square. So we have a into alpha square minus beta square, okay, plus here we have b is common, so we have alpha minus beta and c minus c, this is equal to 0. So again we have here alpha minus beta is common, so we can write here alpha minus beta is common, so we have a into alpha plus beta plus b, so we can write here this is equal to 0. So either this factor is 0 or this factor is 0. So from here we can write alpha is equal to beta. Suppose this is a. Now if we subtract 2 minus 1, we have a into beta square minus gamma square. Here we take a common from the first two term plus b into beta minus gamma and c minus c is equal to 0. So this is equal to 0. Again here b minus beta minus gamma is taken as a common, so beta minus gamma, we have a, this is beta plus gamma. Here a square minus b square is equal to a square, a plus b into a minus b. So this formula is used here plus b. Now see here, this is equal to 0. Again we have one factored beta minus gamma must be equal to 0. So we can write here beta minus gamma is equal to 0. So from here we can write beta is equal to gamma. So from a and b we see that beta is equal to gamma. So we have only two roots. There is no third root of a quadratic equation. So in this case we can say that either alpha is equal to gamma or either beta is equal to gamma. If one root are equal to the another one, so we get only two roots. Now moving to the next slide, we have the nature of root. Now when we find the quadratic equation, roots of the quadratic equation, we get x is equal to minus b plus minus under root b square minus 4ac divided by 2a. Now the nature of roots here depends on the value of a, b and c, that is coefficient of x square, coefficient of x and the constant term c. So here this is under root b square minus 4ac, this is known as d. D is equal to b square minus 4 into a into c. So this is in square root. So if this term discriminant is equal to 0, suppose this is equal to 0 for a particular combination of a, b, c, then we have those term which is in under root, this is equal to 0. So we get only the value of x is minus b over 2a. Here negative sign vanishes, so we have only one root. Okay, so only one root. Now if d is greater than 0, then we get a positive value inside a square root. So we get a real value and we have two value as we get plus and minus sign. So d is greater than 0, we have two real root. Okay, it may be distinct real root, distinct root. Okay, now if d is less than 0, the square root of a negative number is imaginary. So in this case we get imaginary root. So there is no any real value of x for which the given equation is satisfied. So this is the nature of root. We will discuss in later class more about the nature of roots, sign of roots and sign of roots and some questions which is based on these concepts. So for today here we stop our class. In next class we see that graphical representation of quadratic equation, how a quadratic equation can be represented graphically and graphical meaning of nature of roots. So this is our end of the class. If this video is up to you and this is beneficial to you, then please subscribe my channel and share this video more and more. Thank you very much.